In the last lesson, I said that I would show a reaction of water with a neutral base. In the first example, it was with a charged base, the hydroxide ion. So in this case, we're going to look at the reaction of water again. So let's draw our water molecule. With its non-bonded electron pair. And we will react that with, let's use ammonia. And the reason we're going to use ammonia is it is neutral. Now, the ammonia molecule is NH3. We have a central nitrogen atom, and on the nitrogen atom we have a non-bonded electron pair. So if you did your Lewis diagram, this is what you'd end up with, and this is a neutral molecule. Just as a review, remember that your hydrogens are delta positive and the oxygen delta negative in this oxygen-hydrogen bond within the water molecule. In the case of the ammonia, again, the hydrogens are delta positive and the nitrogen is delta negative. So where's the electron density on the ammonia molecule? Well, it's around this nitrogen atom. And this non-bonded electron pair are available for reaction. So we use our curved arrow and we show movement of electrons from an area of high electron density here to low electron density at the hydrogen in the water molecule. The electrons in the oxygen-hydrogen bond are repelled and shift towards the oxygen. What do we end up with as products? Well, this is an equilibrium, and that is the reaction doesn't go to completion to 100%. Once the reaction has stabilized, it's gone as far as it's going to go, there's going to be both reactants and products left in solution. But what do we end up with from the water molecule? Well, it's going to give up a proton. It is a proton donor, just as it was with the hydroxide ion. So when it gives up that proton and those electrons shift to the oxygen, you end up with the hydroxide ion. What's the other product? Well, the ammonia picked up a proton. And the non-bonded electron pair are used to form that bond. Now it picked up a positive charge when it picked up that proton. So the ammonium ion is NH4+, the hydroxide OH-, added together, right side of the equation neutral, left side of the equation neutral, just as it should be. Notice the contrast here between a charged ion, like OH-, and the neutral water molecule. And in that case, we formed OH- charged and a neutral product, and the product was H2O. So when you reacted OH- with H2O, you got OH- and H2O as the products. Next lesson, we'll look at equilibria.